Hi, welcome to the Excel for Statistics class. By the end of this class, you will be able to perform basic business statistics analysis using Microsoft Excel. Then through this class, you will also learn some of the benefits of using Microsoft Excel for daily needs, which will help you to be able to perform better at your job and your business. Okay, let me share the course material first for you. Okay, in this meeting, we will learn about the Excel statistical functions. Okay, so the functions that we will be learned today is chi-square distribution right tail, chi-square distribution, chi-square inverse right tail, chi-square inverse, chi-square test, exponential distribution, F distribution, F distribution right tail, F inverse, F test, Fisher, and Fisher inverse. So all of these functions are distribution as test and test of probability functions. Okay, so let's go to the first function. Okay, for the first one, we have chi-square distribution right tail. Chi-square distribution right tail is a function used to return the right tail probability of the chi-square distribution. The syntax of the function is equal chi-square distribution right tail, open the bracket, x and degree of freedom. For the x is the value at which you want to evaluate the distribution. And then degree of freedom is the number, degree of freedom is the number of degrees of freedom, and it is required. And we have these data sets. You can type these data sets into your Excel first, and after that, you can play this video again. So I hope you already finished the data set. And then for the X, we have 24 in here, and degree of freedom, we have 15 in here. And for the example, equal chi-square distribution right tail, put the X, and then put the degree of freedom. And then the result is 0.06509,349. And then for the other example, we change the X into 12, and then the degree of freedom is 9. So the result is 0.21330931. And then for the next function is chi-square distribution. Chi-square distribution is a function used to determine the chi-square distribution. A function used to determine the chi-square distribution. The syntax of the function is equal chi-square distribution, open the bracket, include the X, degree of freedom, and cumulative. So for the X is the value at which you want to evaluate the distribution, and it is required. For the degree of freedom is the number of degree of freedom and is required. And for the cumulative is a logical value that determines the form of the function. If cumulative is true, chi-square distributions return the cumulative distribution function. If false, it returns the probability density function. And we have this data set. And before we go through the function, I hope you already typed this data set first. You can pause the video, and after that, you can play the video again. Okay, I hope you already finished this data set. And then for the x, we have 17. For the degree of freedom, we have 9. And then for the cumulative, we have false in here. And let's put the function, put the x, put the degree of freedom, and put the false. And then the result is 0.015659. Okay. Oh, but we change the x into 12. Degree of freedom is 9, and then the cumulative is 3. The chi-square distribution will change into the 0.789666907. Okay. And then the next function is chi-square inverse right tail. It's a function used to return the inverse of the right tail probability of the chi-square distribution. A function used to return the inverse of the right tail probability of the chi-square distribution. The syntax of the function is equal chi-square inverse right tail, open the bracket, probability, and degree of freedom, close the bracket. Probability is a probability associated with the chi-square distribution. It is required. Degree of freedom is the number of degree of freedom, and it is required too. And then we have this data set. You can put this data set first into your Excel. You can pause the video, and after that, you can play the video again. So I hope you already finished your data set. So for the probability, we have 0.25 in here. And then for degree of freedom, we have 12 in here. So let's put the chi-square inverse right tail, open the bracket, put the probability, and put degree of freedom. And then the result is 14.845404. Okay. How about we change the probability into 0.1, and degree of freedom is 6. The result of chi-square inversion right tail function will be 10.644641. So this is the result of chi-square inverse right tail from this data set. And then the next function is chi-square inverse. Chi-square inverse is a function used to return the inverse of the left tail probability of the chi-square distribution. The syntax of the function is equal chi-square inverse, open the bracket, probability, and degree of freedom. Okay, so chi-square inverse probability, degree, and freedom. Probability is a probability associated with the chi-square distribution, and it is required. Degree of freedom is the number of degree of freedom, and it is required too. And then we have this kind of data set. Okay, you can put it into your Microsoft Excel first, into your sheet first, and you can pause the video. After you finish the data set, you can play this video again. Okay, I hope you already finished your data set. And then for the probability, we have 0.25. And then for the degree of freedom, we have 9. And then we put the chi-square inverse, open the bracket, put the probability, put the degree of freedom, and then the result is 5.8988259. 9. Okay, so this is the result of the chi-square inverse function. And then we put the new probability, we change the probability into 0.1, and then the degree of freedom to 9 to 6. The chi-square inverse function result for this kind of data set is 2.2041307. And then the next function, chi-square test. Chi-square test is a function used to perform chi-square contingency table test and goodness of fit test. A function used to perform chi-square contingency table test and goodness of fit test. The syntax of the function is equal chi-square test, actual range, and expected range. Chi-square test, open the bracket, actual range, and expected range. Okay, actual range is the range of data that contains observations to test again expected values, and it is required. Expected, and then for the expected range is the range of data that contains the ratio of the product of row totals and column totals to the grain total, and it is required too. And we have the example, the dataset example. You can put the dataset, this dataset into your sheet first. You can type it. You can put pause the video, and then after that, after you finish the dataset, you can play this video again. Okay, I hope you already finished your dataset. So we have high school student, university student in both actual range and expected range. And then we have response for the high school student that say yes is 12, and then university student that say yes is 13, and then we have 13, 12 in here, and then 9 in here, 16 in here, 15 in here, and 10 in here for the expected range. So let's do the chi-square test. We type chi-square test. For the range, we put from the 12 until 12 in here. And then for the expected range, we put 9 until 10 in here. And then the result is 0.1354269. Okay, so this is the results of the chi-square test. And then the next function, exponential distribution. Exponential distribution is a function used to return the exponential distribution. The syntax of the function is equal exponential distributions, open the bracket, x, lambda, and cumulative. X is the value of the function, it is required. The lambda is the parameter value, and it is required too. And then for the cumulative, it's a logical value that indicates which form of the exponential function to provide. If cumulative is true, exponential distribution returns the cumulative distribution function. If false, it returns the probability density function, and it is required. So we have these data sets, and you can type the data set first, this data set first into your Excel. And then after, you can pause the video, and after you finish the data set, you can play this video again. Okay, so I hope you already finished your data set. So for the X, we have 0.5. For the lambda, we have 9. For the cumulative, we have false in here. So we put the exponential distribution function, open the bracket, put the X, put the lambda, and false. And then the result is 0.0999897. So this is the exponential distribution. And then for the F distribution, okay. F distribution is a function used to return the F probability distribution. The syntax of the function is equal F distribution, open the bracket, X degree of freedom 1, degree of freedom 2, and then cumulative, close the bracket. X is the value at which to evaluate the function. It is required. Degree of freedom is the numerator degrees of freedom, and it is required. Degree of freedom 2 is the denominator degrees of freedom. It is required. And cumulative is a logical value that determines the form of the function. If cumulative is true, F distribution returns the cumulative distribution function. If false, it returns the probability density function. So we have these data sets. You can type this data set first into your sheet. You can pause the video, and after you finish the data set, you can play this video again. Okay, so I hope you already finished the data set. So for the X, we have 12 in here. And then for degree of freedom 1, we have 5 in here. And then for degree of freedom 2, we have 3 in here. And then for the cumulative, we have 2. Okay, so the F distribution function would be put the X, put the degree of freedom 1, degree of freedom 2, and cumulative. And then the result is 0.9662174. So this is the F distribution. And then we have F distribution right tail. F distribution right tail is a function used to return the right tail F probability distribution or degree of diversity for 2 datasets. Okay, the syntax of the function is F distribution right tail, open the bracket, X degree of freedom 1, degree of freedom 2, and close the bracket. And then for the X is the value at which to evaluate the function. It is required. Degree of freedom 1 is the numerator, degrees of freedom is required 2. And then degree of freedom 2 is the denominator, degrees of freedom. It is required 2. And then we have this data set. As always, like before, you can type this data set first into your Excel. You can pause the video, and after you finish the data set, you can play this video again. Okay, so I hope you already finished your data set. For the argument, we have X, and then we have 12 for the X, 5 for degree of freedom 1, and 3 for degree of freedom 2. And right now we will try to the F distribution right tail function in here. Open the bracket, put the X, put the degree of freedom 1, and put degree of freedom 2. Enter. The result is 0.033782.6. Okay, and then we will move into the next function, the F inverse. Okay, so the F inverse is a function used to return the inverse of the F probability distribution. The syntax of the function is equal F inverse probability, open the bracket, probability, degree of freedom 1 and degree of freedom 2. And close the bracket. For the probability is a probability associated with the F cumulative distribution. And then for degree of freedom 1 is the numerator degrees of freedom, and it is required. And then for degree of freedom 2 is the denominator degrees of freedom, and it is required too. And then for this example, we have these data sets. You can put these data sets into your Excel first. You can pause the video, and after you finish it, you can play this video again. Okay, I hope you already finished your data set. So the probability, we have 0.1 for the probability. We have 5 for degree of freedom 1 and 3 for degree of freedom 2. And then for the F inverse, we can put F function, F inverse, put the probability, degree of freedom, and then the result is 0.276283. So this is the F inverse function. And then the next function is F test. So F test is a function used to return the results of an F test, the two-tailed probability that the variance in array 1 and array 2 are not significantly different. So F test is a function used to return the results of an F test, the two-tailed probability that the variance in array 1 and array 2 are not significantly different. The syntax of the function is equal F test, open the bracket, array 1, array 2, close the bracket. So for the array 1 is the first array of range of data, and then for the array 2 is the second array of range of data. So we have this data set. For the example, you can put this data set first in your Excel, you can pause the video, and after you finish it, you can play this video again. Okay, I hope you already finished your data set. So we have day 1 and day 2 in here. So let's try to do the F test. Okay, we type F test, open the bracket, array 1 and array 2. And then the result is 0.56735,753 for this data set. Okay, so this is the F test function. Okay, the next one is Fisher function. Fisher function is a function used to return the Fisher transformation at x. The syntax of the function is equal Fisher x, open the bracket, x, close the bracket. X is the numeric value for which you want the transformation. It is required. So for the example, we have x in here for the argument, and for the data, we put 0.5 for the x. Okay, let's do the Fisher function. Fisher, open the bracket, put the x, and then the result is 0.5493061 for this data. Okay, so this is the Fisher function. And then the last one is the Fisher inverse. Okay, sorry. Okay, Fisher inverse is a function used to return the inverse of the Fisher transformation. The syntax of the function is equal Fisher, open the bracket, y, close the bracket. Y is the value of v for which you want to perform the inverse of the transformation, and it is required. And then for the y, we have 0.752. Okay, let's just do our inverse function, put the y. And then for the Fisher inverse function for the 0.752 is 0.63634061. Okay, so this is the Fisher inverse function. Okay, I think that's all for now. You already learned about the chi-square distribution right tail function under the Fisher inverse function. I hope this course material really helps you in your deep learn into the Microsoft Excel. So see you in the next course, and goodbye.